Okay, today what you're going to be doing, today's Wednesday, so hopefully you got the right video going. But today what you're going to do is solve equations with radicals. So if you don't have the sheet already, I would get that passed out at this point and pause if you need to on the video. So what we're going to be doing then is solving some equations. I'm going to walk through a couple of the problems with you. If I go too quick or you find that you're not able to write everything down as fast, pause it please. So here we go. So we're going to start with the first one on the page, and actually you have the equation 3 equals the square root of 4x minus 3. Now, as you recall, what we've learned earlier this week, or actually the day before, that if you have the square root of x, that's the same as x to the 1/2 power. Now, what we're really trying to do here is get x to be, to get x to the first power. We want to know what 1x is equal to, or in other words, x to the first. So you could think of this as 3 equals 4x minus 3 to the 1/2 power. So in order to make this into a power of 1, if you square both sides like we've talked about with the rules of exponents, power to a power just becomes 1. So we have 4x minus 3. Well, we square the other side, we get 9. Now I'll just simply solve that equation like you have been since kindergarten. So you 4x, now divide by 4, so x is 3. Final answer. So basically what you want to do is, if you change it first, to the fractional power, square both sides. Some of you might realize, you can, once you get good at this, in the first step right here, rather than writing it as a half power, just square that. Now, one thing that happens when you do these, you need to check. Sometimes there's what they call extraneous solutions. You have to make sure this solution works. So here's our check. Just put the number in. You can use a calculator quickly, and you just take the square root of 4 times 3 minus 3, so you get the square root of, in this case it would be 9, which is 3. And that equals, now it's not because x equals 3, that's just a coincidence, but 3 equals 3. So that's the first one. So you might run into, like number 2, now have just a little different step here. 3 minus 11n, right? Then minus 3 equals 3. So in this case, we want to get the squared, the square root by itself. Simply just add 3 to both sides first. Then you end up with a problem just like we did a moment ago. Now, like I said, you could just square both of these and see that this is 36. You have 3 minus 11n. Subtract 3 from both sides. Negative 11n equals 33. Divide by negative 11, n is negative 3 in this case. So they're really obsessed, this sheet was, with 3's apparently. But so again, check it. Again, what I'm going to do is just, here's our check. We're going to take the square root of 3 minus 11 times negative 3. So what you end up, square root of 3 plus 33, which equals square root of 36, which is 6. And then, if you look back, the equation then is what we just figured out was, what we need to do is 6 minus 3 equal to 3, and yes, that checks out. 3 equals 3. So we had this minus 3 over here, we had to subtract from the 6. Now I did mention extraneous solutions. Basically what we're looking at, and if you want to think about this, if I have, in this case, the square root of x equals 2, we'll just look at a real simple problem. Well, if I square both sides here, and just to explain what an extraneous solution is what I'm doing now. This is not on your sheet, but if you square the square root of x, you end up with just x. Excuse me, I didn't want that problem. I wanted to show you the square root of x equal to negative 2. This one will have extraneous solutions. If you square both sides, I apologize for that mistake, but here we go. So you square the square root, you end up with, you're going to end up with x, right? So you get x on this side you get 4. Well, if if I take the square root of 4, you'll notice it's not equal to negative 2. Now, in this case, what has happened, basically we've realized, that, you introduce sometimes by squaring, you get rid of negatives and you'll introduce and get what you call an extraneous solution. So that's again why you have to check. All right, so now we're going to move on to some other problems on your sheet, what you have in front of you now. We're going to look at number 7. So number 7 on the sheet, you'd see you have two radicals equal to each other. Now you can think about this just logically and think, well, if I've got two square roots that are equal, the parts underneath the radicals have to be equal. X plus 9 has to equal negative 3 minus 3x. You could just set those equal to each other. Mathematically, you could think about it in this way. What you have is you're going to take x plus 9, again, to the 1/2 power, square that, and it has to be equal to negative 3 minus 3x to the 1/2 power, just changing the radical into the notations, and we're squaring both sides. Either way, you can just think of it as you take away the radical sign. Those parts have to be the same. Now solve the equation. A number of ways to do that. If you want to move the x's to the left, you can. So we add 3x to both sides, and then we're going to subtract 9. So we end up with 4x equals negative 12, and then, so that means x equals negative 3. Well, make sure you check it. Again, what we need to have is the square root of negative 3 plus 9. We're asking, is that equal to the square root of negative 3 minus 3 times negative 3? And in this case, over here, you get the square root of 6. And then on the other side, you have negative 3, then will become plus 9. So you have the square root of 6 again. So that does check out, and your check worked. So you can be confident your answer is x equal to negative 3. One last problem going to go through. You'll have, again, some time to work through these. These are just some notes. Is when you get down to the back page, there are some items to take a look at. Number 11, for example. Now what you have is a variable on the other side. So we have the square root of 20 minus k. Well, same thing as we've been doing. To get rid of the radical, you're going to square both sides. When you do this, you end up with k squared. On the right, you have 20 minus k. So we've got a power of 2. Quadratics are back. They never actually went away. That was last unit. We ran into them again. How do you solve it? Got to set it equal to 0. Subtract 20 and then add k to both sides. So if you subtract 20 and add a k, this side becomes, the right side will become 0. K squared plus k minus 20. Now you could go ahead and use the quadratic formula here on this, or again, simply factor it. Multiplies the negative 20, adds up to negative 1. Those two numbers, positive 5, negative 4. So that means k equals negative 5, or k equals 4. Now, if you try these, I think what you want to understand is that, you might run into a extraneous solution. If you try 4, what you come up with is 4 equals the square root of 16. Well, and 4 does equal 4. So that worked. Okay, so that one's okay. But now if you try negative 5, you have negative 5 equals the square root of 20 minus negative 5. So you're asking if that works. Well, negative 5 equal to the square root of 25, which is 5. And notice those are not the same. So you have to throw out, there's that extraneous solution. And your only solution is k equal to 4. So make sure you check them. So good luck, and we'll see you, well, there'll be another video coming, but you will tomorrow, but we'll see you on Monday.